Albert Einstein, born on the 14th of March, 1879, was a German-born theoretical physicist, widely regarded as one of the greatest scientists of all time. Einstein is best known for developing the theory of relativity, and he also made important contributions to the development of quantum mechanics. Relativity and quantum mechanics are two pillars of modern physics. His works are also known for their influence on the philosophy of science. Einstein's most famous equation is the mass-energy equivalence formula, E equals mc squared, which has been called the most famous equation in the world. Einstein received the Nobel Prize in Physics in 1921 for his services to theoretical physics, and in particular for his discovery of the law of the photoelectric effect, which was a major step in the development of quantum theory. Early in his career, Einstein argued that Newtonian mechanics could no longer reconcile the laws of classical mechanics with the laws of electromagnetic fields. This led him to develop the special theory of relativity while working at the Swiss Patent Office in Bern from 1902 to 1909. However, he realized that the principles of relativity could also be extended to gravitational fields, and he published a paper on general relativity in 1916 with his theory of gravitation. Einstein continued to investigate problems in statistical mechanics and quantum theory, leading to his explanations of particle theory and molecular motion. Einstein also investigated the thermal content of light, which laid the foundation for the photon theory of light. In 1917, he applied the general theory of relativity to model the structure of the universe. After spending a year in Prague, Einstein lived in Switzerland from 1895 to 1914, renouncing his German citizenship in 1896, and graduated from the Swiss Federal Polytechnic, later Eidgenössische Technische Hochschule, ETH, in Zurich in 1900. After living statelessly for more than 5 years, Einstein acquired Swiss citizenship in 1901, which he retained for the rest of his life. In 1905, he was awarded a Doctor of Philosophy by the University of Zurich. That same year, Einstein published 4 groundbreaking papers on his Annus Mirabilis, which is Latin for miracle year, which led to his entry into academia at the age of 26. Einstein taught theoretical physics in Zurich from 1912 to 1914, then moved to Berlin and became a member of the Prussian Academy of Sciences. Einstein published over 300 scientific papers and over 150 non-scientific works. His intellectual achievements and originality made the word Einstein synonymous with genius. According to Eugene Wigner, Einstein's insight was deeper than John von Neumann's. His mind was sharper and more original than von Neumann's, and it was a very remarkable mind. Einstein made a paper, namely the Annus Mirabilis Papers, which contained 4 articles discussing the photoelectric effect, which gave birth to quantum theory, Brownian motion, the special theory of relativity, and E equals mc squared, which Einstein published in the scientific journal Annalen der Physik in 1905. These 4 works contributed significantly to the foundations of modern physics and changed the view of space, time, and matter. The 4 papers were a heuristic viewpoint concerning the production and transformation of light, the motion of small particles suspended in a stationary fluid, as required by the kinetic molecular theory of heat, the electrodynamics of moving bodies, and whether the humidity of a body depends on its energy content. Then statistical mechanics, thermodynamic fluctuations, and statistical physics. Einstein's first paper, submitted in 1900 to the journal Annalen der Physik, was on capillarity. It was published in 1901 under the title Folgerungen aus den Capillaritätserscheinungen, which translates as Conclusions from Capillary Phenomena. 2 papers published in 1902 to 1903, Thermodynamics, attempted to interpret atomic phenomena from a statistical point of view. These papers were the basis for his 1905 paper on Brownian motion, which showed that Brownian motion was strong evidence for the existence of molecules. His research in 1903 and 1904 was mainly concerned with the effect of atomic size on diffusion phenomena, theory of critical opalescence, Einstein returned to the problem of thermodynamic fluctuations, experimenting with the density of a liquid at its critical point. The density fluctuations were controlled by the second derivative of the free energy associated with the density. At the critical point, this derivative became zero, leading to large fluctuations. The effect of the density fluctuations was that light of all wavelengths was scattered, causing the fluid to appear milky white. Einstein attributed this phenomenon to Rayleigh scattering, which occurs when the size of the fluctuations is much smaller than the wavelength, which explains why the sky is blue. Einstein quantitatively obtained critical opalescence from experiments on density fluctuations and showed how the Rayleigh effect and scattering arose from the atomic constitution of matter. Special relativity theory. History of special relativity. The paper Zur Electrodynamik bewegter Körper, Electrodynamics of Moving Bodies, was accepted on the 30th of June 1905 and published on the 26th of September of that year. It unified Maxwell's equations, the laws of electricity and magnetism, with Newton's laws of mechanics by introducing changes to the laws of mechanics. Observationally, the effects of these changes were most noticeable at high speeds, where objects move close to the speed of light. The theory developed in this paper became known as Einstein's special theory of relativity. The paper calculated that when measured by a moving observer, the clock carried by a moving object would experience dilation, and the object itself would contract in the direction of its motion. The paper also stated that the idea of the luminiferous ether, one of the leading theoretical entities in physics at the time, was no longer relevant. In his paper on mass-energy equivalence, Einstein created the formula E equals c squared as a consequence of the special equations of relativity. Einstein's 1905 work on relativity was debated for many years, but was gradually accepted by leading physicists, starting with Max Planck. General relativity theory. General relativity is a theory of gravity developed by Einstein between 1907 and 1915. According to general relativity, the observed gravitational attraction of a mass to an object is due to the curvature of space and time by that mass. General relativity has become an important theory in modern astrophysics. It is the basis for understanding black holes, regions of space where the gravitational attraction is so strong that not even light can escape. Einstein's reason for developing general relativity stemmed from his dissatisfaction with the preference for inertial motion in special relativity. As a result, in 1907, he published an article on the acceleration of special relativity. In the article, entitled "The Principles of Relativity and Their Conclusions," he argued that free fall is inertial motion and that the rules of special relativity must be applied to the observation of free fall. This argument is called the equivalence principle. In the same article, Einstein also proposed the phenomena of gravitational time dilation, gravitational redshift, and the deflection of light. In 1911, Einstein published a paper entitled "The Effect of Gravitation on the Propagation of Light," followed by a 1907 paper on the estimation of the amount of deflection of light by massive objects. Thus, the theoretical predictions of general relativity could be tested experimentally for the first time. Gravitational wave theory. In 1916, Einstein observed gravitational waves, ripples in the curvature of spacetime that propagate as waves, moving outward from a source carrying gravitational radiation energy. The existence of gravitational waves is proven by general relativity through Lorentz invariance, which creates the concept of a physical interaction of gravity with a finite propagation speed. In contrast, gravitational waves cannot be proven by Newton's theory of gravity, which states that the physical interaction of gravity propagates at infinite speed. Then other theories include physical cosmology theory, pseudotensor momentum energy theory, wormhole theory, Einstein Cartan theory, motion equation theory, old quantum theory, quantized atomic vibration theory, and many other Einstein theories that have not been mentioned. Einstein also did other research which failed and was then abandoned. This research is related to force, superconductivity, and other research. On 17 April 1955, Einstein suffered internal bleeding from a ruptured abdominal aortic aneurysm, which had been surgically tightened by Rudolf Nissen in 1948. He was taken to the hospital and drafted a speech he was preparing for a television appearance to commemorate the 7th anniversary of the State of Israel, but did not finish it. Einstein refused surgery, saying, "I want to go when I want to. It is tasteless to prolong life unnaturally. I have finished my business. It is time to go. I will do it gracefully." Einstein died at Princeton Hospital the next morning at the age of 76, having continued working until the end of his life. At the autopsy, Princeton Hospital pathologist Thomas Stoltz Harvey removed Einstein's brain for preservation without his family's permission, in the hope that future neuroscience might discover the cause of Einstein's extraordinary intelligence. Einstein was cremated and his ashes scattered at an undisclosed location.